Hey, welcome back. Today we're going to be talking about how a tsunami forms. And how we're going to do this is we're going to take a look at another content creator's animation and talk through it because it has a very useful animation and video set to talk through. A lot of concepts in physical science and geology and physics here are presented in a very short amount of time, so it's actually very valuable to talk through this. Let's go ahead and get to it. I do want to say at the outset that this is a subduction zone, and there is a continental plate on the upper right and a oceanic plate in the upper left. And the oceanic plate is thinner but also more dense than the continental plate. I want you to imagine all of the material more or less in a continental plate squished down, and on top of that there's a bunch of water on top of the oceanic plate, which means it's actually much more dense than the continental plate. And so when they come together, when there's a convergent plate boundary like we're going to see here, the oceanic plate subducts. That means it gets driven underneath the continental plates. These are driven together by the convection currents in the mantle, and so that's the beginning of this animation here as to where we're starting with this. Okay, and what you're going to see in this pink line region is where you have such tremendous friction between the subducted oceanic plate and the continental plate that the continental plates, it basically gets stuck to some of the top layer of the subducting oceanic plate as it goes down underneath. And as it gets stuck, it gets driven back, and then you have a tremendous amount of friction that locks it in place. In the meantime, there is a tremendous amount of stress building up. So this stress and elastic potential energy starts to build up in the upper right continental plate. So I want you to notice that. Okay, so I want you to imagine there is a tremendous amount of stress building up. We've talked in a little more detail about stress. I'll put a link to that lesson in the upper right about now if you want more about that. And in the process of these two plates being locked together because of the friction, you also have a tremendous amount of elastic potential energy building up. That's the type of potential energy that we have with springs. This upper layer, this continental plate, is behaving almost like a spring in the sense that it's storing a tremendous amount of energy that will eventually be released as the deformation happens, and then it essentially will rebound to something like its more original position. Okay, and so that's how a tsunami can happen. You have this locking and release of energy every several hundred years. Like 200 to 1,000 years, you get this build up of tremendous stress and pressure and force, and eventually the continental plate rebounds to more of its original position, and as it does so, it lifts water tremendously higher up in the ocean temporarily. That happens very quickly, but then you have this like mountain of water or hill of water out in the middle of the ocean, and that mountain of water needs to flatten out. And so when it flattens out, it's got tremendous speed and it spreads all across oceans oftentimes, and it can flood coastal areas, doing tremendous damage. I've done lessons on an entire year of physics as well as most of the ideas for AP Physics C mechanics, so if you have any further questions down below, please let me know. Take care, and I hope you have a great day.